So number 3, part A, they ask us to sketch a velocity time graph, which I've done here. And take note, of course, you mark the origin, label the axes, time, velocity, and the units there, meters per second, and seconds there for time. That's so important you do that. Now, this lift, right, it's got 3 stages, if you like, to its journey, okay? So you can't really use Suvat throughout the whole thing, right? You have to do it in each stage, because the acceleration changes, okay? In each of the 3 stages. That's why velocity time graph is really good. And it says, doesn't it, for the first 15 seconds of its journey, it accelerates. And it accelerates from rest. So velocity is 0 when t is 0 for the first 15 seconds. Okay, and then, so we've got that there. So t is 15. It then says it travels at this constant speed then of 2.7 meters per second for 90 seconds. What I need to do here now is appreciate now it's going to be constant speed. Okay, so we're going to have a flat line, okay, whereby it's going at this speed of 2.7 following the initial acceleration. And that's 90 seconds. So if you think about it, it took 15 seconds to accelerate, 90 seconds then it goes at this constant speed. So now we're up to 105, aren't we? Okay. And then it says the lift then, what happens to it? Decelerating uniformly to rest. So if you think about it then, a further 15 seconds, it gets to rest. Okay, so it's kind of nice and symmetrical, because that takes us to 120. We're told, don't we, that the whole journey time is 2 minutes, 120 seconds. So this is identical to this. Okay, the acceleration is identical to the deceleration. Of course, one is positive, one is going to be negative, isn't it? So, sketch a velocity time graph. Well, we've done that, I mean, everything's in here. Part B then says calculate the distance travelled by the lift. So we could say, for part B, total distance, okay, is equal to the area under the graph, okay. Now, this we could think of as 1 if we want, or 2 triangles and a rectangle, doesn't matter. If we take as 1, we've got a trapezium, haven't we? Okay, so in this case, my A is this parallel side here, which is 120, and then the side is parallel to is 90, times then the height between them, which is 2.7. So if I work that out, it comes out to be 283.5 meters. Okay. It says then a woman of mass 75 kilograms is standing on the floor lift during its journey. Calculate the reaction exerted by the floor of the lift on the woman when the lift is accelerating. Okay, so if we want the reaction, okay, it is accelerating, right, and from the ground floor to the top floor. Let's think about what we need. Well, the reaction on this lady, okay, we call R, and her weight will be 75g. Okay, so to work out R, we need A, don't we? Okay, we need A. And to get A, we just need to establish what A is. So you can get it from here, can't you? Remember, acceleration is the gradient, isn't it? Okay, so the gradient. And the gradient in this case will be, well, the rise divided by the step. So 2.7 divided by 15. You could use Suvat here. Okay, so we'll do that. Comes out to be 0.18 meters per second squared. So then using Newton's second law here, okay, I got the reaction on the lady from the left, take away then her weight, that's the resultant force, equals then to her mass times the acceleration. So R will equal to then, well, if I work that out, that comes to be 13.5, and then take that 75g over to the side. So it comes out to be 748.5 newtons.